Well, hello again, and welcome to part 2 of week 11 of cis204, Unix shell scripting and utilities, and today we're talking about awk again. We talked about awk in week 10, and we're talking about it again in week 11. And we left off looking at a odd duck little awk file called password check. Well, let's take a peek at that again for grins. More password underbar check. Let's see this for example. So here's another version of that. Kind of odd duck in the sense that it looks for the number of fields, then it looks to see if field 1 is not alphanumeric, then it looks to see if field 2 has the splat in it, which would mean that the password isn't there. So if I do a diff on passwd underbar check and a passwd wd underbar check dot awk, there's none. So that works out just fine. It's the same thing. So, okay. Let's move forward. So we used awk in this case to validate whether or not the pieces in the password file were correct. Works fine for that. We can do comparison expressions within awk, which is even more fun because now you can get away with a little bit of some math in here. Okay, and awk does math better than the shell does math, and we'll see that as we go forward. So let's take a peek here. Let's see what happens when we do this check to see if $3 is greater than or equal to 5346 in employees. Found it. Mary Adams. Okay. It just happens to be the employee ID. And why I have a T Mary Adams there, I have no clue. So let's check for those fields in those records in the employees file where the ID or the employee ID is greater than 5,000, and that's field $3. Again, the entire record is $0. First field $1, second field $2, and if you remember correctly, we had in the howdydoody.txt file, we had some records that had 64 fields in them. Doesn't make any difference. You can have a variable number of fields on each record. Again, this is text processing. So what did it find? Well, in this case, what it did is it found one line whose field 3 was greater than 5,000, and it printed the first field in that line. So what have I got? I've got a pattern. Check to see if field 3 is greater than 5,000, and if you do find a field 3 that's greater than 5,000, then print the first field. So how can I make that a little bit better? Because that T Mary Adams is not really all that whippy. $2, yep, we'll just do $2. How's that? Yep, doesn't like that. Syntax error. Let's see what happens. There it is. Trying to give it too much information. And again, notice what you got out of this as far as an error file. Syntax error, expected new line or end of string. So because of that extra comma in there, it blew up. It blewed up good, as David Hobbs would say. So now let's take a look at this. In this case, I'm looking to see if field 2 contains Adam, contains the string Adam, just as that is written, A-D-A-M, the capital A in the front. Found it. Why did it find it? Because Adam, A-D-A-M, is buried inside that field. That, because of this tilde, It says find the string in the field. It doesn't say the field has to match the string. It just says find the string in the field. So let's try that again. In this case, we'll put the not in front of it. Then we get the other lines. For grins, let's take a look at employees. Only 4 lines in it. Okay. So now, how about this? Let's clean this up a little bit here. Paste that in there. Max dot text. So what's going to happen here? I'm going to set something where if $1 is greater than $2, then set 1 to max, else set 2 to max. And that's what if and kind of an else there. So let's more max.text, right? Yeah. Let's more max.text without the caps locks on. So 17 is greater than 10, yeah. 12 is greater than 4, so there's 1 worked. 195 is definitely greater than 22, that worked. 1 is greater than 0.5. Now this is significant because this is telling me that unlike bash, awk will handle floating point. Okay. Jim, 40 is greater than 3, you betcha. 57 is greater than 3, and 186 is greater than 45, and 7 is greater than 3. Good. Did exactly what we wanted it to. How about this? If $1 times $2 is greater than 15 in max test, find those lines. Those are the lines where $1 times $2 is greater than 15. So who fell out? Bert. Yeah, even some more fun ones. So how about this? Logical records. Let's take a look. What am I doing here? If $2 is greater than 5 and $2 is less than 200, then show me the records. There they are. Compare those to what's actually in there. So Bob's $2 was 17, it's greater than 5, and it's less than 200. So I found 195, which made sense, but it couldn't find Bill because Bill's $2 was not greater than 5. It didn't find Bert's. It didn't find Sam's. But it found Solomon's, John's, Jim's, Shelley's, and Bob's, which is what we'd expect. So something was working right here. What about this? In this case, what I'm looking for is if $2 is equal to 195 or $2 is less than 5. So who should I get? Well, I should get Shelley because her $2 equals 195. I should also get Bill, Sam, and Bert. Worked just like I expected it to. Isn't that special? So let's try this one. Again, this one basically says if $2 is less than 5 and $1 is less than 10. So who am I going to match here? Well, I know I'm going to match Bert. Should match Bert. And I won't match Bill. I shouldn't match Bob. I shouldn't match Shelley. I shouldn't match Jim, Sam, John, or Solomon. And that's exactly what happened. It matched Bert. Ooh. Now, if I found Bert with that, who should I find with this? Yeah, pardon me. Who should I find with this? I should find everybody I didn't find the first time. Sure enough, don't find Bert, but I find Bob, Bill, Shelley, Jim, Sam, John, and Solomon. Good deal. Okay. So let's take a look at max.text one more time. Now, what about this? What's going on here? If $1 is greater than 5, then print $3. Just give me the name. What am I looking at? Well, I've got an action here. I've got a pattern that I'm matching. In other words, I want to do this relational operator. If $1 is greater than 5, and then I have an action, which is print $3. Give me the name. So $1 greater than 5, 10, 12, 22, 57, 45. 10 is Bob, 12 is Bill, 22 is Shelley, 57 is Sam, 45 is John. It did exactly what we expected it to. Now, how about arithmetic operators? I can do all kinds of fun things in here. So let's clean this up again. Kick those out. Spit this in. Put a T on the end of it. So what am I doing here? If $1 is greater than $2, then take $1 times $2 and print $3. So what am I going to get? Well, I should get a single number. So for Bill, which is 12 and it's greater than 10, $1 is greater than 10, 12 times 4 is 48. Cool, it worked. It did exactly what you expected it to do. But here's the fun thing. It was doing math in the output. What if I do this? What should I get? If $1 is greater than $10, then divide $2 by 3 and print the field 3. 1.333, 65, 1, and 62. Okay. Four divided by 3 is 1.333 every day of the week. How about this one? So what am I asking for here? Well, again, $1 greater than 10, and then I'm going to divide 2 by 3 and spit out the remainder. The percent is the modulus operation. So where should I get a remainder from? Well, from Bill. No remainders in Shelley, Sam, or John, because those were all whole numbers in the division. But I do have a remainder with Bill, a modulus. Okay, cool. Now, I want to make this a little bit easier on the eyes, right? So let's do this. Oh, that's not good. Well, you know what? Let's take a look at this. Again, defeated by Microsoft quotes. Now, there it is. Bill, Sally, Sam, and John. Okay. So let's do this. Yep. Let's do this. And we're going to have to go in and clean up these quotes. we're going to have to do something really bad here. Max.text. Okay, 12.4, and it replaced $3 with William and then printed it. What is it in the file? Well, it's still Bill in the file because awk did not overwrite the max.text file. In this case, it looked for field 3 equaling Bill, and then it said replace your notion of field 3 with William, and then print field 3, or actually print $0. I didn't have to specify the $0. I could specify the $0, however, and I should get the same thing. So there you go. Isn't that special? Now, how about this one? What's going to happen here? Let's clear this out more. Max.text. So this is looking at $3. If Bert's contained within the field 3, then take $2 and add 4 to it and print 4.5 Bert. Worked like a champ. So you see we're getting there. This is beginning to make some sense. Okay, awk contains a number of built-in variables, and they have uppercase names. And you know, this is one of those things I've been harping on. Variables should contain uppercase names. File name equal the name of the current input file. FNR, the number of records in the current file. FS, the input field separator. RS, the record separator. NF equal the number of fields in the current record. Records being a line. NR, the number of records so far, in other words, the line number. OFMT, the output format for records. The OFS, the output field separator. There are some additional awk variables. Environ equal an array containing current environment variables. Rlength, the length of a matched string. Argc, the number of the command line argument. Argindex, index of the argv of the current line. Argv, an array of command line arguments. Gawk only variables. These are outside of the original awk, but now are included in the GNU awk. Is that convert format, conversion format for numbers, and ignore case, turn off case sensitivity. The user can also define variables. The user-defined variables will consist of letters, digits, and underscores. You can't begin the variable with a digit, just like regular work. The variables are not declared. You don't have to say this is the variable. It kind of follows along with what bash does. Data type is inferred by context. In other words, it interprets what you're giving it to determine if it's a string or digits. An uninitialized variable will be set to null for strings and 0 for numbers. So variables, numeric and string contents. Numeric contents can be integers, floating points, or use scientific notation. Strings are enclosed in double quotes. Remember our substitution of William for Bill? We put that inside double quotes. Initialization and type coercion. In other words, it's being coerced into being this type of a thing. You mention a variable which will cause it to exist. If it's something that it can't interpret, it becomes a variable. Type is determined by expression on the right-hand side of the equal sign. So A is going to equal 37, that's a number. B equal quotes 38, that will coerce that B into being a string. So let's stop here. This is the end of part 2, and we'll pick this up in part 3 of week 11, cis204, Unix shell scripting and utilities.